Last video we covered the aesthetic. This one we're going to cover the actual, circuits inside, because otherwise you're just all show and no go and nobody likes that. Real basic primer on instrument amps. Now, I don't even know where to start on this, so let me liken instrument amps to automobiles or something like that. Amp types are as varied as automobiles and as specific, like purpose-built, as automobiles. So, for instance, you could take like a pickup truck and enter it in the Indy 500, but it's not going to work very well at all. You could take a Prius and enter it in a monster truck competition, but it's really not going to work very well at all. That's why when you go into a recording studio, often they will have an entire wall of amps and amps heads. Wait, obligatory disclaimer here, we are going to be working with lethal voltages, so bear that in mind. Okay, here you go. So I tried recording this part a few times and I realized how difficult it was going to be for me to wrap up an entire industry, but at the end of this video, after the credits, I'll run down, just rattle off the specs of the amp and some of the weird things about it, just for the, amp nerds that may wander onto this video. I also found myself tap dancing on eggshells, trying to avoid kicking over several different types of cans of several different types of worms. So we're just going to handle things pretty generally, and I'll give you a broad overview if you're a complete noob when it comes to this type of stuff. And in the future, I'll do more specific things. It's just not somewhere I want to take this channel at this point in time. If you haven't figured it out already, by nature of the large ceramic sockets that are mounted in the chassis, we are going to be playing with vacuum tubes, specifically 12AX7s and EL34s. Now, I know that particular choice of tubes is not exactly groundbreaking. It's used in quite a few different hi-fi and guitar amps. But if you're building something for someone who's going to be gigging on it and traveling around, you want them to be able to get, spare parts if these blow up, since they are just glorified light bulbs after all. Construction-wise, I decided to go with a turret board with flying leads. Now, I don't always do it this way, but I already had this turret board staked, as I mentioned in a previous video, so I figured I'd just go ahead with that. Now, I am what they call in the tube world a heretic or a heretical builder, meaning that I have no problem using solid state where solid state is more appropriate. That leads to some very interesting construction, especially when you're doing a turret board type thing, because solid state naturally leans toward PCBs, specifically PCBs and surface mount parts if you're using pick and place automated machines to make these. So in my stuff, typically the core of the circuit goes on the turret strip, and then I have flying leads to the tube sockets, to the controls, and then snippets of PC boards for the sort of solid state or the helper circuits and that type of thing. That lets me lay things out so that it's easier for somebody if they have to service this amp when I'm not around and they have to take it to some other service place. It's easier for them to see the layout of the core of the circuit, but it takes the solid state stuff and puts it on a little module that's easy to swap out if something goes goofy with that. And since I did a lot of custom order, design to order type of stuff, that made it very easy to mod the values of the components in the, the core of the circuit, the tone and response sculpting part of the circuit. Now, I know this may be a shock to some of you, but it's not 1968 anymore, and the demands of electronics are a lot different than they were then, so we can't just do everything like Leo and Jim and RCA did it back in the day. Mains filtering and power conditioners are pretty much a necessity these days, unless you just kind of deal with all that nonsense. But a lot of musicians go with these type of rack mount power conditioners. However, this particular fellow that I was building this for doesn't do the rack mount thing, and I knew he wasn't using any kind of power conditioner. Now, traditionally, the power supplies in these are very basic, just transformer coupled. So you have your mains voltage coming in, you have a step-up coil to your high voltage or your B+, and then you have a step-down coil to feed your filaments, the heaters for the vacuum tubes, which means that any noise that comes in is going to be inductively coupled into your output coils, and there's usually no filtering at all. So any noise that rides in on our AC main supply is going to ride in our AC filament supply, be shot into the cathodes of our tube, and radiate all of the chassis. Good times. So we're going to include a simple mains filter. I know that sounds like a no-brainer to all of you out there, except those of you who are into vintage audio gear, because since that's not how Jim and Leo and RCA did it back in the day, that's not how a lot of the people who clone vintage amps do it these days. But regardless, I just sketched out the simplest two-stage circuit that I could with both differential mode and common mode filters, and slapped that on the input on a little tiny bit of PC board. Okay, Alex, seriously, that sounds crazy. Nobody uses those types of power supplies anymore for virtually anything except for some wall warts, and even those are going the way of the dodo. Now hold on there. These are some of the areas that I don't want to tread into to this video because it requires running down some rabbit holes. You see, the thing is, a lot of genres of music got their sound around abusing equipment in particular ways. So when you treat equipment in a particular way, such as, taking a 100-watt Marshall amp, turning it up to 11 and tearing off the knobs, then everything is a part of it, including the power supply. Now let me explain very quickly just one aspect of that, and then you'll see how that can feed into many, many other parts of the circuit. For this example, I'm going to use sag, which is a characteristic that's either very desirable or very undesirable, depending on what type of music you want to play. So I'm going to walk you through this just so that you can get a feel for how complicated this becomes and how specific to particular genres it is. So typically preamplifiers were just cascaded Class A grounded cathode preamp stages leading into some kind of phase splitter that led into a pair of output tubes, or more than a pair, depending on how much wattage you need. But that is the point of this, because the previously Class A power output stages, if you're talking about like Class A1 single-ended with, probably loaded with a transformer, you're only going to reach like 18, 19, 20% efficiency. So if you want to economize a little bit better, well, how do we up the efficiency? All we could really do is split the phase and go to a push-pull amplifier in just shallow of Class C, because once you start to get Class C and above, then you're getting into nonlinear amplifier territory, and it's just a lot of noise on top of your signal. Nowadays, especially with like digital modeling amplifiers and things like that, I think all of those output stages are like Class D, PWM, solid state amplifiers and whatnot. But regardless, back then it was Class shallow C, like hot AB push-pull amps working on the power tubes that they could at the time. Now, speaking of the power supply, to save cashola, we were talking about like high impedance cascaded RC and LC power supplies. So you're familiar with the term like PI filter or pi filter. A lot of these were just capacitive input. So you had center tapped power transformers that are going to a full wave rectifier, not a full wave bridge, a full wave rectifier, often with vacuum tube rectifiers, later on silicone rectifiers. But that fed into typically a large bulk capacitance, which and that node fed the pair of output tubes plates. Then there was either a resistor or a inductor, because you could get, as you know, a much steeper low pass filter with just a single inductor. So you have less voltage drop, hence less wasted power per component, even though it cost you a little bit more. And then that fed the screens, which drew a lot less current. Now the problem was, since these were push-pull Class AB, not pure Class A amplifiers, depending on how much power you were drawing through the tubes, it was going to draw different amounts of current through this very high impedance power supply. There's a point to this, stick with me here. Well, now you slam that cord and you have this instantaneous draw of current through the output tubes that's going to cause a drop in voltage on your B+ rail, your main voltage rail, which is just cascaded all the way down to the input of your amplifier. Every stage is fed from that rail sequentially, one after the other, decoupled by more and more RC stages. You have this dynamic effect where boom, hit a loud note, voltage sucks down, voltage goes back up. So the power supply becomes a part of the response and the tone of that amplifier, because all your operating points are dancing around depending on where that rail voltage is. So that is just one of the small aspects of how the design of an amplifier, even its power supply, affects the sound and response of the amp. And it gives you a small peek into why musicians get really weird about the gear that they use, or we're very specific about the type of gear that they use. Now, if you're playing much more modern style, which can use a much stiffer power supply because they want tightness as opposed to sag, which is what the phenomenon that which is what guitar players call that phenomenon, then you can get away with much more modern power supplies. But if you're trying to build or design an amp for a dude who may or may not want sag, depending on how he sets the amp, well, you want to have low noise like a modern amp, but you want to preserve that type of feel like an older amp. So you could purposely introduce completely unnecessary series resistance in your power supply line while still using modern regulator or modern regulator circuits like capacitance multipliers or gyrators or things like that, which consequently is what I do. And it'll be cascaded a couple times. So I'll have usually like a regulator for the screens or for the phase inverter, and then one or two regulators in the preamp circuit so that you filter everything out before it gets to the low level noise sensitive stuff. So yeah, take that last couple minutes of dialogue there, multiply it by 1,000 across all the different parts of the circuits and variants, and now you can understand why I didn't want to open up all those various cans of worms. And eventually in the future, I'll talk more about some of my favorite Heretical audio circuits, probably not the immediate future, so don't worry about that, like plate constant current sources and long tail phase inverter current sinks and things like that that are kind of no-brainers to modern designers, but incorporating them into like the older style stuff to solve particular problems is a little bit, like I said, rare and shunned in Heretical. So, whole thing's together now, just doing a point-to-point test with a regular old multimeter, make sure everything is about where that it should be, at least in reasonable places, then time to do the terrifying first power-up. This will give you a nice view if it blows up. So I had no squealing, no magic spoke, and no splodey. And then comes a fun part, which is just playing around with the amp and actually tweaking the tone, going back and forth with customers, seeing what they like, and making it happen. I know I did my job if I want to keep the thing, and I definitely wanted to keep this amp. And when he heard the first clips, he was extremely happy with it too, which is good because, it's a lot of work if you want to have a back and forth, and I was a little pressed for time. So finally, glam shot time. This is what we ended up with after about, 13, 14 days worth of work going into this. During that period in the summer where I told all of you that I had to take a mental health break and do some other things because things got pretty hectic. So yeah, these are the pics I sent off to him, and he basically blew a fuse. He freaking loved it. As you can see, the faceplate came out much different than I had originally planned. I wanted it more of like a steampunky industrial thing. This came out more of like a, this actually kind of looks like oiled bronze as opposed to like, patinaed copper, but that's fine. The knobs were actually anodized aluminum, meant to look like brass. The inserts were plastic, little knurled inserts to keep it on the shaft around the lights and the switches and the potentiometers and things like that. And those were basically just all like plumbing fittings I grabbed from a hardware store. And of course, sound clip time to be sent off to the dude. So this is recorded with this guitar, which this is a DIY Frankenstrat that I put together in this exact same time period. And I just laid down some generic blues rock. This amp left and right rhythm with this amp right down the middle as a solo. All three tracks were recorded through a DIY 112 cab with a GreenMachine speaker from Ear Candy and a 797 audio LDC mic. Alright, if you stuck around, here's 10 minutes of rambling. I'm kind of being quiet here because it's late at night. Sorry. I'll walk you through the basics of the circuit here. Since this was designed for a dude and not for me or for a project, like I don't want to put the schematic up. Maybe in the future, if I talk to him again or get retubed or something like that, I'll ask if that's cool. But at the basics, just like a 3-stage amp, and this kind of developed from If you go to alexdennis.com, that'll redirect you to my blog, and there's in the little search bar in the upper right, just type in Megadeth. So like 5 years ago, I did a Megadeth cover with some friends of mine and used a amp that I kind of used as the basis of this. It's the amp that I have been using in the meantime, but this was much more of a rock-oriented one. And that amp was to experiment with like how much gain you can get out of three gain stages, three cascaded gain stages. The challenge with that is if you hit it too hard, it just tubs out, and if you don't hit it hard enough, then you never get past like kind of that a heavy crunch into a nice saturated like modern high gain type territory. And it's tough to get it into that territory, but if you listen to that Megadeth cover, those guitars are all that amp. So anyway, this was a kind of a dialed back version of that, but some of the things I liked from that, this dude was interested in as well, so I kept those. One of the things I like with, particularly when you're doing this sort of in-betweeny amp, is when you can dial in the amount of low end going into the preamp, and that low end characteristic of the first couple gain stages really sets the feel of the amplifier. Like if you have a huge bypass capacitor on like your first gain stage leading into like a 4-stage amp or something like that, it's pretty tubby. You're never going to get that tightened up to where it's nice and like you need for a lot of modern music. So I'll do out of the first stage, which I always treat the first stage like a hi-fi amp, and just try to make it as like clinical as possible, like widest voltage swing as possible, lowest noise as possible. So that usually gets like a high gain triode and like a constant current source load for the like an active CCS load on the plate, feeding that into a adjustable high pass circuit to tighten up the lows, in addition to like the customary low shelf filtering from the cathode RC negative degenerative feedback circuit and all that. That goes into peaking circuit or shelving circuit, however you want to look at it. It's either high shelf or a high peak, high mid peak, or low shelf, whatever. The gain obviously goes after the first stage as per usual, and then I had an additional peaking circuit after that because I really had to sculpt the lower mids going into that second section if I was going to hit it pretty hard, because that second section, where if this were like a Marshall or like something that had its heritage going back to like the GCM 800s or the Plexis or something like that, would probably be like an unbypassed like 10K or higher resistor in the cathode of that second stage. So this is not quite it's cooler biased, but not like 10K cooler biased, or like Soldano 39K cooler biased. It's like 4-ish, and it's bypassed, not fully bypassed, so partially bypassed. I don't exactly remember which value, probably like around a microfarad-ish, plus or minus. Going into another high pass, another peaking, so no sense in just letting extra noise on the low end go through, and that goes into a more treble sculpted third stage, because that's where you're going to get a lot more of the upper harmonics that you're going to want to tame down. And added like that was the third stage, definitely into DC coupled cathode follower as per tradition, but with a stopper on it to preserve the longevity of the tube and to prevent any oscillation or anything like that. That fed standard master volume into treble middle bass, like Marshall style tone stack, but with adjustable slope resistor, and the values are different, and the mid-range knob does some little tricks that I like and things like that. But essentially it's like a regular Marshall-esque TMB sort of tone stack. That feeding into just a regular long tail pair. Well, I say regular, into a long tail pair stage, but I like when long tail pair. Oh, that's hard to say. Long tail pairs are forced symmetrical. First off, it's lower noise. Second off, it's less unevenness in the output stage, and it just, the whole thing sounds cleaner to me. So I force symmetry with a constant current sync, and with that, of course, if you're going to be driving that phase splitter really hard, you're gonna want to reference it to a negative voltage, so you don't end up with very asymmetrical clipping there. And that's something that really has to kind of be tweaked with an oscilloscope and by ear. Also, I tend to not bootstrap my long tail pairs like you would see in like a Marshall or something like that. I'm not exactly positive why they started doing that. Maybe to have a convenient place to put global feedback, but I add global feedback to the non-inverting input on the other side just through a regular old voltage divider from whatever the feedback resistor would be. I don't remember if I used active EQ in the feedback loop. I usually always do put some kind of active EQ in the global feedback loop. That's sort of customary. A lot of times I'll just do like a Baxendall type thing, like a treble and a bass control in there, so you have like presence and like resonance or thump or whatever they want to call it. Tweak that clipping by ear to sort of figure out where you want the or how much high end you want going into it and coming out of that into the output stage. And then the output stage was just a pair of EL34s. I had a quad of old like Siemens German EL34s, which were pretty good, so I popped 2 of those in there for him. But I also gave him a pair of like JJ EL34s, or no, Electro Voice EL34s. I used to use JJ EL34s for everything because they were super reliable, but not as much these days. But the Electro Harmonix ones, the skinny bottle ones, even though they don't sound as like big and beefy, they seem to last longer. They're a little bit more rugged. They're kind of that like Siemens German looking design with the big fins on the top of the getter halo and all that stuff. Yeah, where was I? Oh yeah, EL34s, but it's a dual grid bias and cathode bias type system. It's not really auto bias because it is adjustable within a range, but I wanted it so that he could plunk in anything in that like pentode tetrode kind of family and it would be fine. So excuse me, I don't remember exactly what reflected load I used for the plate to plate load on the output transformer, but it was just sort of neutral in the midst of all that like EL34, 6L6, 6550, KT66, KT88, you know, E34L kind of family, so that he could basically drop whatever in there and it would be safe, but it could be biased, you know, colder if it was too hot for whatever he wanted to play. I also had a tricky little circuit to the output that was, you could probably see it if you rewind back in the video and look along the back wall of the chassis. A couple aluminum bodied power resistors there. That's to make sure like if it's like a built-in like power soak type deal, dummy load. So if you knock the cabinet wire out or something like that, it doesn't toast your output transformer, because that happens occasionally, like on stage somebody kicks it out or pulls it out in practice, or your amp falls over or something like that. So anyway, it's also split so that you can plug in the middle of the 2 resistors and get like built-in half power type output, or pull it out completely, and there's another output that's tapped off of it with a potentiometer that you can use just to feed a DI signal. It's like a post, it's basically speaker level DI signal. That's, I don't remember if I got around to transformer isolating it or not. Well, I meant to do a 1-to-1 isolation transformer to make sure there's no like weird ground loop problems if you're interfacing with a computer, into like a potentiometer, like 10K potentiometer, to go out to send a mono post transformer signal out for recording, if you wanted to DI capturing the entirety of the amp as opposed to just like the preamp, since this amp was meant it has pre and post phase inverter master volumes in addition to the power soak at the end. So essentially it has like 4 different gains, and you can balance, depending on where you want it to play, between the preamp, the phase inverter, or power amp distortion. So anyway, yeah, that's why I had to put an output speaker level, because if you just tapped it at like where the effects loop would go, there's no effects loop, by the way, because that would just ruin the whole thing. You wouldn't get the clipping power of the output of the amp anyway. Anyways, that's all. Catch you later.